Results are located in the Results folder listed in the Simulation Study Tree. By default, 3 types of results are available: stress, displacement, and strain. Each item represents a plot, or graphical representation of our results. To activate a plot, I can right-click and select Show, or I can simply double-click the name of the plot. At the top left of the graphics area, you'll see a description of the plot you're viewing. Notice the plot has a deformation scale of more than 150. This means the results I'm seeing on the screen are actually exaggerated to a level 150 times greater than the actual deformation of the plate. This is done to improve visibility, since in most cases deformation will be so small that it's not actually noticeable. Also, notice we have a legend on the right side, which tells us how the colors in the plot relate to different stress levels. A simulation will automatically create the range for this legend from the minimum stress to the maximum stress. You'll also see the yield strength for the material being used. This value is highlighted in the legend to show where the yield strength occurs. In our example, I can see that the red areas exceed the yield strength of this material. Now, this tells me the plate will likely fail under the conditions I've tested. In addition to reviewing the stress plot, I also like to reassure myself that the part is generally behaving the way I expected. I can do this by animating the plot. To activate the animation, I can right-click on the plot from the Simulation Study Tree, or I can select Animate from the drop-down of the Plot Tools icon in the Simulation toolbar. In the Animation Property Manager, I can set the number of frames I wish to use and the speed of the animation, larger numbers resulting in a faster animation, lower numbers resulting in a slower animation. I'll set my animation to use 10 frames and use a speed of 20. As you can see, you also have the option of saving the animation as an AVI file. This would be useful if I wanted to include this animation in a presentation, or perhaps send it to someone else for viewing. Because it's a standalone AVI file, the recipient would not need SOLIDWORKS simulation software to view it. I'll skip this option for now and simply click the play button to view the animation. Now, as you can see, the animation is set to reciprocate. That is, it plays forward to the deformed state, then reverses, returning to the unreformed state. You can change this animation to only play forward, or to loop by using the buttons in the Animation Property Manager. Animations are useful in validating your common sense expectation of how your model should behave. In this example, I expected one end of the plate to remain stationary, which it is, and I expected the plate to stretch in the direction of the pulling force. Seeing this animation validates what I expected and gives me confidence that I correctly defined my testing conditions in simulation. In some cases, you'll run an animation and find that the part is doing something completely unexpected. While the animation might still be correct, seeing unexpected behavior will cause you to review your steps and make sure you set up your problem correctly. In the next lesson, we'll do more with our stress plot.